There are diseases that affect exactly one person in the world. Not one demographic group, not one specific family, not one isolated geographic city, but one single, solitary human being. Out of the 8 billion individuals currently walking the surface of this planet. To understand the profound weight of this reality, one must step back and contemplate the sheer, crushing scale of this biological isolation. For millennia, the entire edifice of human medicine has been constructed upon a single foundational principle: the identification of patterns. From the ancient shamans cataloging roots to the modern clinical trial protocols of the 21st century, science has progressed by looking for what unifies the sick. We have historically sought out shared symptoms, identical viral loads, common environmental exposures, and universal physiological vulnerabilities. The entire economic and structural engine of global pharmaceuticals was designed to answer this call of commonality. It learned to mass-produce small molecules and synthetic compounds in billions of identical blisters, aiming deliberately at a construct known as the average person. The infrastructure of global health required this abstraction to function. It required the individual to be subsumed into the statistic, because the machinery of industrial chemistry could only find economic viability in numbers. But what happens when you do not fit the standard? What happens when your personal, existential, biological glitch is as utterly unique to you as the exact whorls of your fingerprints or the constellation of lines across your retina? What happens when your suffering cannot be categorized under a mass statistical heading? Until the dawn of the third decade of the 21st century, there was simply no salvation for individuals trapped in this space. This structural abandonment was not born from the inherent cruelty of medical professionals, nor was it a failure of basic scientific curiosity. Rather, it was a logical and unavoidable consequence of the way human civilization organized its resources. To develop a novel therapeutic agent from scratch, to subject it to the brutal, multi-phase gauntlet of modern clinical trials, and to invest hundreds of millions or even billions of capitalistic dollars for the sole benefit of a single patient was a fundamental oxymoron. It was an impossible mathematical and economic equation that could not be forced into any existing market or state-sponsored model of healthcare. Consequently, ultra-rare or orphan patients existed as mere statistical noise. They were the unavoidable friction of a blind evolutionary process, a tragic but necessary mathematical error rate in the reproduction of the species. They were human beings doomed to suffer and fade away in the sterile silence of diagnostic waiting rooms, hidden behind rare Latin names that no local doctor had ever heard of, and that no pharmaceutical company could ever afford to fix. But on February 25th, 2025, that unyielding structural wall cracked down its center. In the quiet, intensely monitored environment of the Children's Hospital of Philadelphia, a medical team administered a simple intravenous injection to an infant named K.J. Muldoon. The clear fluid within that syringe did not originate from a mass manufacturing plant in Europe or Asia. It had never sat on a pallet in a regional distribution warehouse. It did not possess a commercial brand name, nor would it ever be indexed in a standard medical formulary. It had been designed, synthesized, purified, and bottled exclusively for him. From the earliest days of his life, KJ had been diagnosed with an exceptionally severe deficiency of the carbamoyl phosphate synthetase, one enzyme, a devastatingly rare anomaly within the human urea cycle. Under normal conditions, this specific enzymatic pathway is responsible for the vital task of converting toxic ammonia, the natural byproduct of protein metabolism, into urea, which can then be safely excreted by the body. Without this functioning biological pathway, ammonia accumulated relentlessly within the infant's bloodstream every hour, every minute, and every second. It acted as an endogenous neurotoxin, slowly and systematically causing cerebral edema, cognitive destruction, and eventual coma. In the vast majority of historical cases, this specific mutation resulted in a rapid, agonizing death within the first few weeks of life. The only traditional, long-term intervention available to modern medicine was a complete liver transplant. However, for an infant as systematically exhausted, small, and hemodynamically fragile as KJ, the trauma of major transplant surgery was itself a near-certain death sentence. The child was caught in a classic, lethal medical paradox. It was at this juncture that doctors Rebecca Ahrens-Nicholas and Kiran Musunuru chose to reject the historical inevitability of the child's diagnosis. They realized that the rapidly advancing state of genetic science allowed for a total reversal of the medical paradigm. Instead of spending months or years fruitlessly scouring the global pharmaceutical network for a pre-existing drug that might match the patient's symptoms, they decided to engineer a completely new molecular countermeasure tailored directly to the specific, single-point genetic typo within this individual boy's DNA. To achieve this, they turned to the bleeding edge of gene editing technology, a process known as base editing. Developed originally in the academic laboratories of David Liu, base editing represents the current architectural zenith of the evolution of genetic tools. While the first-generation CRISPR-Cas9 systems functioned essentially as molecular scissors that cut completely through the double strand of DNA, relying on the cell's somewhat erratic, error-prone natural repair mechanisms to glue the ends back together, base editing works with the precision of a microscopic word processor. It does not cleave the structural backbone of the DNA. Instead, it uses a guide RNA to locate an exact coordinate within the 3 billion-letter text of the human genome and chemically transforms one single nitrogenous base into another. It turns a single cytosine into a thymine, or an adenine into a guanine. It fixes a singular typographical error in the blueprint of life without leaving scars on the surrounding genetic landscape, and without risking the chaotic structural deletions that plagued earlier methodologies. The timeline of this intervention was as revolutionary as the technology itself. Less than 6 calendar months elapsed between the initial, terrifying diagnostic consultation with the boy's parents and the moment the finished, custom-tailored syringe was brought into the clinical room. By the middle of 2026, the tangible results of this gamble were undeniable. KJ Muldoon was not merely surviving, he was thriving. He was walking across the linoleum floors of the clinic, smiling at his caretakers and actively learning to speak his first words. His liver, now reprogrammed at the deepest cellular level, was producing the missing enzyme with flawless efficiency, clearing the toxic ammonia from his brain before it could cause harm. The custom-designed molecular sequence that saved his life will never be administered to another human being on this planet. It is an entirely bespoke piece of biological software, written to address one specific mutation at one precise locus within one singular genome. The event in Philadelphia was not an isolated medical miracle, nor should it be viewed merely as an act of desperate clinical bravery. It was the historical manifestation of a massive, systemic, and irreversible tectonic shift. It was the exact coordinate in human history where 4 completely independent scientific and technological trajectories which had been developing in parallel across the globe for generations, finally intersected to create an entirely new civilizational capability. The first thread in this historical convergence is the staggering, near-exponential collapse of the cost of reading the blueprint of life. To appreciate where we stand in 2026, we must look back to the year 1990, when an international coalition of states launched the Human Genome Project. At the time, the ambition to read the 3 billion base pairs of a single human being's DNA was widely viewed as a scientific project akin to the Apollo program. It required 13 years of continuous, grueling effort from hundreds of coordinated laboratories across the globe, consuming approximately $2.7 billion of public and private capital. The completion of that draft in 2003 was hailed as a monumental geopolitical achievement. Yet, the true revolution lay not in the completion of that first map, but in the subsequent destruction of the economic barriers to accessing it. By the year 2026, the cost of fully sequencing a human genome has dropped to less than $100. Companies like Ultima Genomics now routinely deploy advanced high-throughput sequencers capable of processing up to 60,000 complete genomes annually within a single, self-contained machine. It is vital to recognize what has actually altered across this 36-year span. The fundamental complexity of the human genome has not diminished by a single base pair. It remains a vast, labyrinthine sequence of 3 billion chemical characters. What has shifted is our civilizational capacity to handle that staggering complexity quickly, cheaply, and routinely. Reading the code of life has been permanently transformed from a multi-billion-dollar geopolitical feat into an unremarked, routine clinical checkup that can be ordered by any rural practitioner. The second thread running through this singularity is the rapid stabilization and industrialization of gene editing tools. For over a decade following the seminal discoveries of Jennifer Doudna and Emmanuel Charpentier in 2012, genetic editing remained a delicate, often temperamental art confined primarily to academic research benches and specialized oncology laboratories. The true turning point arrived in December of 2023, when the United States Food and Drug Administration officially approved Casgevy, the first commercial therapy utilizing CRISPR-Cas9 for the treatment of sickle cell anemia. Casgevy represented a triumph of mass production logic. It was a single, standardized genetic cure designed once to treat an identical, widespread mutation shared by 16,000 patients across the United States. It was the pharmaceutical factory model applied to the genome. However, the true significance of Casgevy's success was that it thoroughly validated the safety, predictability, and systemic viability of intracellular genetic modification within actual human patients. It proved that the cellular machinery could be reprogrammed without catastrophic long-term side effects. The case of K.J. Muldoon in Philadelphia took this validated toolset and applied it to the exact opposite economic paradigm. It proved that genetic editing had become so mathematically precise and predictable that science no longer needed the financial crutch of a mass production model. The tools had evolved from a rigid industrial stamping press into a highly flexible digital design workstation. The technology was now capable of craft, bespoke modeling, allowing a small team of clinicians to adjust the molecular machinery for a singular individual with absolute confidence. The third thread represents the total elimination of what had historically been the most significant intellectual bottleneck in biological science: the structural prediction of proteins. For over half a century, one of the most frustrating challenges in biology was the protein folding problem. While scientists could easily read the linear sequence of amino acids that made up a specific gene, they remained largely blind to the physical, three-dimensional shape that those amino acids would fold into once synthesized within the cell. Because a protein's function is dictated entirely by its physical shape, its microscopic valleys, ridges, and binding pockets, knowing the genetic sequence was like having a list of parts without a blueprint of the assembled machine. To determine the physical structure of a single protein, a dedicated laboratory historically had to endure months or even years of painstaking, expensive X-ray crystallography, nuclear magnetic resonance spectroscopy, or cryo-electron microscopy. The entire global sum of human knowledge regarding protein structures was a hard-won, painfully slow accumulation. Then came the introduction of advanced artificial intelligence networks, culminating in systems like AlphaFold. By the mid-2020s, these neural networks had completely bypassed the physical constraints of the laboratory. In a matter of mere computational seconds, the AI could predict the highly complex, three-dimensional structure of virtually any protein sequence presented to it. AlphaFold single-handedly mapped the physical structures of over 200 million proteins, effectively charting the entire known biological world, and placing that data into an open-source, universally accessible repository. When the medical team in Philadelphia discovered KJ's unique mutation, they did not have to embark on a multi-year academic research project to figure out how that specific genetic typo was sabotaging his metabolism. They simply queried a digital database. The artificial intelligence instantly visualized the broken protein, showing the exact structural collapse caused by the single missing base pair. The intellectual bottleneck that had broken the spirit of generations of medical researchers was utterly dissolved. The fourth and final thread is perhaps the most surprising, yet it is arguably the most critical for the democratization of this technology: the profound evolution of regulatory bureaucracy. Historically, the state apparatus for approving new medicines was a slow, conservative monolith designed explicitly to regulate mass-market industrial chemistry. The traditional approval pathway enforced by agencies like the FDA was built around multi-phase clinical trials that required testing a standardized compound on hundreds, then thousands, of identical human subjects over many years to establish statistical safety and efficacy profiles. This model was completely incompatible with the reality of individualized genetic medicine. If a drug is designed for a mutation that exists in only one person on Earth, it is a physical and mathematical impossibility to conduct a traditional multi-center, placebo-controlled trial. To force bespoke genetics into the old regulatory framework was to effectively outlaw the technology entirely. The breakthrough came in February of 2026, when the FDA officially published its draft of the Plausible Mechanism Framework. This administrative document introduced a revolutionary legal concept: the Master Protocol. Under this new regulatory paradigm, the state shifted its focus away from evaluating the specific, individual sequence of chemical letters contained within a custom syringe. Instead, the regulators focused on validating the safety of the underlying delivery platform, the molecular vehicle, and the editing enzyme itself. If the platform could be proven systematically safe through standardized, rigorous benchmarks, clinicians were granted the legal authority to swap out the internal genetic code to match a specific patient's mutation without being forced to restart the multi-year, multi-million-dollar trial process from scratch. The bureaucracy had finally adapted to the speed of digital biology. When these four threads, hyper-cheap sequencing, standardized editing platforms, AI-driven structural modeling, and adaptive regulatory frameworks, converged in that hospital room in Philadelphia, they did something far greater than save the life of a single boy. They created a profound historical precedent. They proved that the biological code of the human species had permanently transitioned from an immutable, fatalistic decree written in stone into a dynamic piece of digital software. A software application where any line, any word, and any individual letter could be edited, reprogrammed, and updated in real time. At this precise coordinate, human history splits in two. The technological capability is now established, and it cannot be undiscovered. Civilization now faces a profound choice, a grand fork in the road that will define the next 2 centuries of our evolutionary trajectory. Before us lie 2 distinct, coherent, and absolute futures: the dark descent into an unequal, corporate-owned genetic abyss, or the ascent into a radiant, decentralized utopia of liberated human potential. In the decades following the stabilization of personalized genetic medicine, the global free market makes a definitive, unyielding assessment. Human life is the ultimate high-margin commodity. The initial, idealistic dreams of open-source science and universal genetic access are rapidly dismantled by the brutal, systemic realities of venture capital, intellectual property litigation, and corporate consolidation. The technologies of bespoke molecular synthesis and real-time genome correction are not integrated into public infrastructure. Instead, they are wrapped in dense layers of aggressive patent protection, corporate trade secrets, and non-disclosure agreements. By the year 2066, the global pharmaceutical landscape has consolidated into 3 all-powerful, transnational life science conglomerates. These megacorporations do not merely own the factories that produce medicine. They have successfully privatized the actual informational architecture of the human genome itself. Utilizing highly sophisticated legal precedents established during the early days of synthetic biology, these conglomerates systematically patent specific sequences of nucleotides, regulatory genetic circuits, and metabolic pathways. If a child is born with a unique, naturally occurring mutation that happens to utilize or cross an informational pathway that has been patented by a corporate entity, the child's parents do not possess the legal right to alter that sequence using open-source tools. To do so is classified as a severe infringement of intellectual property, an act of biological piracy. The individual is born as a literal, involuntary tenant of a proprietary genetic block. This absolute monetization of the biological blueprint gives rise to a rigid, neo-feudal caste system based entirely on genomic architecture. The old social markers of wealth, class, and education are replaced by a far more permanent, immutable biological reality. Society splits cleanly into 2 distinct evolutionary tiers. The first tier is a small, insular, and immensely powerful caste known across the globe as the enhanced. These are the individuals whose families possess the astronomical capital required to purchase premium, pre-implantation genetic design packages and lifelong, proactive genomic updates. The enhanced do not leave their offspring to the chaotic, random mutations of the genetic casino. Their children are engineered before conception within sterile, high-end corporate clinics. They are born with completely optimized genomes. Their immune systems are hard-coded with synthetic broad-spectrum antibodies that render them completely immune to all known viral and bacterial pathogens. Their metabolic pathways are tuned to prevent the accumulation of visceral fat, arterial plaque, or cellular senescent toxins. Their neurological architectures are enhanced with optimized neurotransmitter receptor densities, granting them near photographic memory, hyper-focused attention spans, and an innate resilience to emotional trauma. Furthermore, the enhanced have successfully deactivated the genetic switches responsible for systemic biological aging. Their cellular telomeres are continuously repaired by engineered, self-regulating enzyme cascades. Their organs are maintained in a state of permanent, youthful homeostasis. At 80 or 90 years of age, a member of the enhanced caste possesses the bone density, skin elasticity, cognitive speed, and physical vitality of a 20th century 25-year-old. They are, for all practical intents and purposes, a separate, emerging subspecies of humanity that has bought its way out of the evolutionary struggle. Beneath them lies the vast, overwhelming majority of the global population. A caste known colloquially as the subgenomics, or more bitterly among themselves, as the biodebtors. The subgenomics are those who continue to be born through the old, unedited lottery of natural reproduction. They enter the world carrying the full, accumulated weight of their ancestors' genetic flaws, predispositions, and weaknesses. But in this new world, an unedited genome is no longer viewed as a tragic trick of nature. It is treated as a severe social liability and a personal economic failure. The corporate state utilizes ubiquitous, hyper-cheap genomic sequencing not to heal the subgenomics, but to enforce a total, invisible system of social and financial control. The moment a subgenomic individual applies for employment, a higher education tier, a basic apartment lease, or a line of financial credit, a single drop of blood or a stray skin flake is collected and analyzed by automated corporate algorithms. The neural networks do not look at the individual's resume, character references, or past achievements. They scan the code. The automated system delivers a cold, mathematical verdict detailing the applicant's biological future with absolute predictive certainty. If the code reveals a 74% probability of developing clinical depression within the next 5 years, a 62% chance of early-onset cardiovascular degradation, or a genetic predisposition toward addictive behaviors, the individual's application is instantly, algorithmically denied. The corporate HR system classifies them as an unacceptable long-term investment, a liability to corporate productivity. The subgenomics find themselves trapped in an inescapable biological cage. They are denied the very employment and financial resources they need to purchase the genetic edits that could cure them, simply because their unedited genes make them an employment risk. Furthermore, healthcare for the subgenomic caste transforms into a system of predatory, lifelong biological serfdom. If a biodebtor develops a debilitating genetic condition, corporate medicine does not offer a permanent, curative edit like the one given to K.J. Muldoon in 2025. That would be economically inefficient for the shareholders. Instead, the corporation provides a subscription-based, temporary molecular patch. The patient is placed on a lifelong regimen of proprietary synthetic compounds that must be taken every single month to keep their condition in check. The cost of these subscriptions is pegged precisely to the maximum economic output of the individual. The biodebtor spends their entire working life in a state of perpetual financial exhaustion, handing over their wages to the life science conglomerates just to buy the next 30 days of biological survival. Their body is a literal profit-generating asset for the corporation. A closed economic loop where suffering is systematically monetized until the day the individual can no longer afford the subscription fee. At which point, the automated delivery system shuts off and nature takes its delayed, predictable course. As the decades roll on into the late 21st century, the extreme centralization of genetic power inevitably provokes an equally extreme, violent counter-reaction. The tools of DNA synthesis, computational modeling, and intracellular delivery cannot be kept confined within the clean, guarded laboratories of the megacorporations forever. The underlying science is digital, and digital information wants to be free, even if it has to escape through the darkest channels of the human underground. In the decaying, forgotten industrial sectors of the world's megacities, a sprawling black market ecosystem emerges. These are the domains of the splicers, the rogue biohackers, and the genetic outlaws operating within the dark net. In damp, subterranean basements lit by the flickering glare of salvaged monitors, using home-brewed biological 3D printers constructed from black market components and stolen industrial parts. These underground engineers attempt to replicate the miracles of the elite. The darknet biohackers offer cheap, unverified genetic patches to the desperate subgenomics. They sell black market immunity boosters, bootleg neurological enhancement serums, and unregulated metabolic overrides designed to burn fat or increase muscle mass without exercise. But these basement laboratories lack the rigorous quality controls, quantum error correction arrays, and deep AI simulation capabilities of the corporate complexes. The results of this black market splicing are frequently catastrophic. A bootleg genetic patch designed to increase cognitive speed can trigger unexpected, runaway oncogenesis in the prefrontal cortex, turning a patient into a terminal cancer victim within weeks. An unregulated muscular enhancement virus can cross the blood-brain barrier and cause profound, irreversible neurological degradation, inducing violent psychotic breaks or total motor paralysis. The lower depths of society become a chaotic, horrific testing ground for unstable, fragmented biological code, where millions of desperate people willingly gamble with their lives, injecting unverified viral vectors in a frantic attempt to escape their caste. Yet, the true horror of this decentralized biological capability manifests not in the tragedies of accidental contamination, but in the deliberate development of personalized genetic terrorism. By the year 2110, the classical methods of kinetic warfare and mass destruction terrorism, bombs, missiles, chemical gases, and indiscriminate biological plagues, have become entirely obsolete. They are too messy, too politically costly, and too easily intercepted by the advanced automated defense networks of the corporate enclaves. In their place arises the age of the surgical, individual-specific bioweapon. In this dark reality, a political assassination or the elimination of a corporate dissident requires no gunfire, no explosive charges, and no physical confrontation. A state intelligence agency or a well-funded terrorist cell simply needs to acquire a clean sample of the target's genetic sequence. This data is easily obtained. A wine glass left at a restaurant, a discarded tissue, or a digital break-in into an unsecured dental database is all it takes to download the target's entire 3 billion-letter blueprint. Once the target's unique genomic profile is loaded into an underground synthesis array, specialized algorithms scan the text for a highly specific, idiosyncratic vulnerability. A minor, harmless sequence of non-coding DNA, or a unique combination of immune cell receptors that exists in that specific human being and nowhere else on Earth. The hackers then design a custom, synthetic pathogen tailored explicitly to match that exact genetic coordinate. This personalized virus is then released into the general population of a city or an office complex. For 99.999% of the population, the virus is an absolute ghost. It has no binding affinity for their cells. It causes no symptoms, triggers no immune alarm, and passes through their respiratory tracts as a completely harmless, unremarked passenger. The thousands of people who breathe it in go about their daily lives in perfect health, acting as unconscious, highly effective vectors of transmission. But the moment this phantom pathogen comes into contact with the one specific individual for whom it was written, its molecular keys match the target's unique cellular locks. The virus activates with lethal force. It enters the target's cells, bypasses their personal immune defenses, and initiates an immediate, runaway physiological collapse. The target might drop dead of an apparent, sudden massive stroke at their desk, or collapse from an acute, untreatable hemorrhagic shock within their own home. When the medical examiners perform an autopsy, they find only what appears to be a tragic, sudden natural organ failure. There is no trace of foreign chemical toxins, no structural trauma, and no evidence of an epidemic outbreak in the surrounding community. The weapon was invisible. It was completely untraceable, and it self-destructed at the molecular level the moment its singular task was completed. The entire global landscape becomes a silent, paranoid minefield for anyone of geopolitical or financial importance, forcing the elite to live within completely sealed, bio-isolated biobubbles, terrified of breathing any air that has not been scrubbed by multi-layered defensive AI algorithms. By the dawn of the 23rd century, the cumulative effects of 200 years of genetic stratification, corporate standardization, and predatory optimization bring the human species to its ultimate, ironic crisis: a complete biological dead end. The pursuit of genetic perfection within the enhanced caste, combined with the corporate drive to standardize human biology for maximum economic predictability across the subgenomics, has systematically purged the human species of its most valuable evolutionary asset: its chaotic, messy, and unpredictable genetic diversity. For nearly 2 centuries, parents who could afford genetic design packages consistently chose the same highly marketed, culturally celebrated traits for their children. They selected the same narrow ranges of facial symmetry, the same optimized metabolic profiles, the same heightened neural configurations, and the same specific variations of immune response. The major life science corporations encourage this trend, actively patenting a small, standardized selection of ideal genomic templates and selling them to billions of consumers worldwide. Slowly, imperceptibly, over the course of generations, the rich, chaotic, and incredibly complex tapestry of human variation was ironed flat. The human population became an extreme biological monoculture, vastly similar to the industrial agricultural plantations of the 20th century, where entire contents of crops were grown as genetically identical clones of a single successful plant. The historic anomalies, the strange genetic mutations, the odd physical variations, and the hidden biological weaknesses that had traditionally caused suffering, but had also provided the species with its evolutionary resilience, were entirely wiped clean. Humanity had successfully insulated itself from the natural world, turning its own body into a beautifully designed, flawlessly engineered, and legally protected piece of proprietary corporate software. And then, the natural world does what it has always done for 4 billion years. It shifts. Deep within some unmonitored, rapidly warming equatorial ecosystem, or perhaps within the unstable, decaying depths of an underground biohacking sector, a completely novel pathogen emerges. It is a virus that does not rely on the standard cellular entry pathways that modern medicine has spent centuries guarding. It utilizes a completely unmapped, highly specific structural vulnerability that happens to be an accidental, universal byproduct of the standardized, perfect metabolic template shared by 95% of the living human population. Because the entire human species has been standardized around this identical genetic blueprint, there is absolutely no variation in the population's immune response to this new threat. The classic bells of the evolutionary curve have been smashed flat. In a natural, unedited population, a sudden, brutal pandemic will kill a percentage of the people. But a small group of genetic outliers, individuals with strange, anomalous immune systems or odd cellular receptors, will always possess an innate, accidental resistance. Those outliers survive, pass on their genes, and ensure that the species continues. But in the year 2226, there are no outliers left. There's no wild genetic frontier. Every human being possesses the same optimized, premium-grade, corporate-approved cellular architecture. The new pathogen tears through the global population with an efficiency that defies description. It does not encounter a single wall of natural biological resistance. What kills one corporate executive in a sealed penthouse kills a factory worker in the lower sectors and an orbital technician in a space station with the exact same speed and certainty. The very genetic optimizations that had promised to grant humanity absolute safety turn out to be the ultimate instrument of its collective execution. Civilization collapses into an absolute, silent biological void. The brilliantly engineered, patent-protected, and hyper-optimized human species perishes from a simple, unpredicted evolutionary pivot, precisely because it chose to view the code of life as a piece of commercial property rather than a sacred, wild ecosystem that required diversity to survive. Humanity had finally managed to build the perfect golden biological cage for itself, only to realize, as the doors locked forever, that it had forgotten to design a key. We return to the great fork in the road. In this alternate trajectory, humanity stands on the precipice of the genomic revolution in the early 21st century and makes a collective civilizational decision that alters the course of history forever. Recognizing that the code of life is the foundational architectural document of all human experience, an overwhelming global consensus emerges among citizens, scientists, and state actors. Through the ratification of the World Genetic Pact, the human genome is officially declared an absolute, unalienable, and universal humanitarian commons. The legal frameworks of the past are radically overhauled. The patenting of naturally occurring or curative genetic sequences is strictly, globally outlawed, categorized alongside slavery and nuclear proliferation as a supreme crime against humanity. The intellectual property rights of gene editing are shifted entirely to an open-source, non-profit model, ensuring that the software of life can never be converted into a tool of corporate extortion or caste-based subjugation. By the year 2056, this open-source paradigm has completely transformed the physical and economic reality of human healthcare. The old, predatory industrial complexes of Big Pharma, with their multi-billion-dollar manufacturing monopolies, massive global supply chains, and artificial scarcity models, have become entirely obsolete. They have dissolved into the past, replaced by a hyper-local, completely decentralized loop of medical care that brings the singularity point of 2025 directly to every community on the globe. In this world, the very architecture of a medical clinic is rewritten. A hospital is no longer a massive bureaucratic institution filled with rows of beds for the chronically ill and warehouses of expensive, pre-packaged chemicals. Instead, it is a quiet, clean, and highly integrated center of digital biology and localized synthesis. The entire diagnostic and therapeutic cycle operates seamlessly within the space of a single, localized neighborhood facility. The process begins with automated real-time sequencing. If a patient walks into a clinic experiencing any physiological anomaly, or if a newborn child is screened at birth, their complete 3 billion-letter genome is read in a matter of minutes by a non-invasive, hyper-cheap desktop sensor that costs no more than a basic office printer to operate. Once the digital text of the patient's DNA is acquired, it is not sent to a corporate server for proprietary analysis. It is uploaded to a globally shared, completely open-source artificial intelligence network. This digital commons, the direct evolutionary descendant of projects like AlphaFold, instantly compares the patient's individual genome against the global baseline of human variation. The AI does not simply look for known, pre-categorized diseases. It simulates the patient's entire molecular biology in real time. If there is a single misspelled chemical character, a missing base pair, or an anomalous structural fold in an essential metabolic enzyme, the artificial intelligence identifies it in seconds. It visualizes the physical, three-dimensional shape of the broken protein and immediately designs an idealized, custom-tailored guide RNA and base-editing enzyme matrix designed specifically to correct that precise individual typography. The final step in the loop occurs right in the room, at the point of care. The digital blueprint generated by the OpenAI is transmitted to a localized bioprinter sitting on the clinic's counter. This machine, using standardized, non-proprietary chemical cartridges of basic nucleotides and benign delivery vectors, synthesizes the custom molecular patch on the spot. Within a few hours of walking through the clinic doors, the patient is administered an injection that was written, simulated, verified, and printed specifically for their unique biology. The therapeutic intervention is a precise, permanent edit that repairs the root cause of the cellular malfunction at the atomic level. Because the technology is open source and the raw chemical components are incredibly cheap to produce, the cost of this life-saving intervention is virtually non-existent, subsidized by public infrastructure as a basic human right. The concept of an incurable genetic condition, an orphan disease left untreated for lack of profit, or a lifetime spent in financial bondage to pay for maintenance drugs, is completely erased from human experience. The clinics of the world become spaces of absolute healing, from which the ancient shadows of biological despair and structural inequality have been permanently banished. As the open-source genetic revolution deepens and rolls forward into the 22nd century, its effects ripple far beyond the walls of the medical clinic, triggering a profound, civilizational transformation that alters the very architecture of human time, psychology, and social organization. This era becomes known in the history books as the Chrono-Revolution, the moment humanity finally broke the biological tyranny of the hourglass. Throughout the entire previous span of human history, the collective psychological landscape of our species was fundamentally shaped by the absolute brevity of our lifespan. A human being could expect to live perhaps 70 or 80 years, a microscopic blink on any historical or geological scale. This extreme temporal compression forced humanity into a state of permanent, subterranean existential panic. We were forced to compress our lives into frantic, hurried stages. We had to spend the first 2 decades of our existence absorbing a massive amount of dense information through formal education. We had to immediately spend the next 3 decades working at an intense pace to secure economic stability, build infrastructure, and raise the next generation. And then, just as our minds were reaching their absolute zenith of maturity, accumulated wisdom, emotional balance, and deep philosophical understanding, our biological containers began to systematically collapse. The tragic pattern of human civilization was a continuous, heartbreaking leakage of intellectual capital. Just when an engineer, a scientist, an artist, or a philosopher finally understood how to think, how to create, and how to accurately interpret the complexities of the world, their arteries hardened, their neurons degraded, and their physical bodies dissolved into senescent decay. Each new generation was forced to pick up the dropped tools from the dust, spend decades relearning the basic lessons of their ancestors, and repeat the same systemic historical mistakes. We were a species of short-lived temporal refugees, always building, but never living long enough to understand what we had built. The democratization of individual genetic design permanently shatters this cycle. By systematically mapping and deactivating the evolutionary programming responsible for cellular senescence, telomeric shortening, and metabolic decay, open-source science grants every human being the gift of absolute biological stability. The physical body is decoupled from the passage of chronological years. In this new civilizational landscape, 100 years of active, vibrant, and physically flawless health is no longer the rare exception. It becomes the universal baseline, the standard period of human youth. The individual at 90 or 100 years of age possesses the immaculate bone density, clear vision, sharp cognitive processing speed, and radiant physical energy of a 20th century young adult, but combines it with a century's worth of deep internal experience and emotional maturity. This vast expansion of human time triggers an unprecedented liberation of the collective mind. The subterranean existential panic that had driven human greed, short-term consumerist exploitation, and corporate quarterly profit mania is utterly dissolved. Humanity stops living as desperate, short-term temporal raiders on a wounded planet, and begins to think with the grand, patient perspective of geological stewards. The entire structure of human social life is radically redesigned. Education is no longer a frantic, stressful race completed in youth. It transforms into a lifelong, beautiful process of intellectual exploration. A person can afford to spend 30 years mastering the deep intricacies of theoretical physics, then spend the next 40 years becoming an accomplished classical musician, and subsequently dedicate half a century to the study of planetary ecology, knowing that they still have centuries of vibrant, creative life ahead of them. The institutions of governance, science, and art undergo a profound qualitative jump. The leadership of human society is no longer composed of hurried individuals operating on short-term political cycles, desperate to secure their legacy before their health fails. It is guided by experienced, physically youth-sustained long-livers who plan civilizational initiatives on scales of centuries, large-scale projects to completely reverse global climate shifts, to terraform the world's arid deserts into self-sustaining ecosystems, to heal the deep scars left by industrialization, and to construct massive, clean energy infrastructures are designed with absolute confidence. The architects who draw the first lines on the digital blueprints know, with absolute mathematical certainty, that they will be standing on the ground 2 centuries later to witness the final, triumphant dedication of the completed structure. The wisdom of the ages is finally given a permanent, youthful home, and human progress transitions from a series of disjointed, chaotic sprints into a majestic, continuous march forward. The true, ultimate scale of this open-source genetic liberation reveals itself when humanity finally outgrows the planetary cradle of Earth and casts its gaze toward the infinite, challenging frontier of deep space. For generations, the dream of becoming a multiplanetary species was profoundly bottlenecked by a fundamental, insurmountable reality. Human biology was designed explicitly for Earth. Our entire genetic code, from the expression of our bone remodeling proteins to the cellular repair mechanisms within our skin, is intricately, beautifully adapted to the specific conditions of our home planet. A precise atmospheric pressure, a specific blend of nitrogen and oxygen, a stable magnetosphere that deflects cosmic radiation, and a uniform gravitational pull of 1G. Outside this thin, protective blue envelope, the universe is an environment of absolute biological hostility. When 20th century humans attempted to venture into space, their bodies began to systematically unravel within weeks. The absence of gravity caused rapid, catastrophic bone demineralization and muscular atrophy. The relentless bombardment of high-energy cosmic rays shattered their chromosomes, triggering runaway cancers. The psychological isolation within cramped, metal hulls warped their nervous systems. The traditional sci-fi vision of space colonization, building massive, heavy, lead-shielded ships, constructing fragile glass domes over alien dust, or attempting to terraform entire planets to mimic Earth's environment, was a monumentally inefficient approach. It was a desperate attempt to carry the physical prison of our native ecosystem across the stars in heavy, iron cans. The utopia of individualized genetic design completely bypasses this structural bottleneck by introducing a profound philosophical shift. We stop trying to remake the cosmos to fit human biology. We unlock human biology to fit the cosmos. Humanity realizes that the 3 billion-letter genome is not a rigid template that must be preserved exactly as it evolved on Earth. It is a highly flexible, dynamic set of informational instructions. With the tool of real-time genetic editing, our species can consciously adapt itself to thrive within any environmental niche the universe provides. When the great migration ships leave Earth's orbit for the red plains of Mars, the pioneers do not travel as fragile terrestrial refugees huddled inside life support pods. Before departure, their genomes are updated with the Martian biological package, an elegant suite of open-source genetic adjustments engineered to work in harmony with their new home. Their internal bone remodeling pathways are modified at the cellular level, allowing osteoblasts and osteoclasts to maintain an immaculate structural equilibrium in low-gravity environments, completely preventing the onset of space-induced osteoporosis. Their cardiovascular systems are tuned to adjust to lower atmospheric pressures without distress, and the cells of their eyes are optimized to perceive the lower light levels of the distant sun with crystal clarity. They step onto the surface of Mars, not as alien visitors in cumbersome suits, but as native children of the red planet, their bodies perfectly integrated into the physics of their new world. When the scientific expeditions push further out into the frozen, high-radiation environments of the outer solar system to explore the hidden, subterranean liquid oceans of Europa, Ganymede, and Enceladus, the explorers receive an even deeper, more profound genetic modification, drawing upon the ancient, resilient biological code found in Earth's own deep-sea extremophiles, tardigrades, and radiation-resistant bacteria. Open science constructs a revolutionary cellular defense matrix. The explorer's DNA is enhanced with highly active, self-monitoring enzyme cascades that detect cosmic radiation damage the exact millisecond it occurs instantly splicing the broken strands back together with absolute fidelity, rendering them completely immune to radiation sickness and space-induced oncogenesis. Their metabolic pathways are modified to allow for periods of controlled, synthetic metabolic hibernation, a state of safe, deep cellular suspension that enables them to coast through the multi-year voids between planets without consuming precious resources or suffering psychological decay. Over the course of 2 centuries of interstellar exploration, the human species undergoes a glorious, dazzling diversification. We cease to be a single, uniform biological monoculture locked in one rigid form. We transform into a fluid, beautifully varied, and hyper-adaptive cosmic life force. Different branches of the human family tree develop distinct, specialized biological architectures optimized for the worlds they inhabit. Yet, this divergence does not lead to the dark, corporate-owned castes of the alternate timeline. Because the technology remains open source, universally shared, and grounded in a deep philosophical respect for the collective human spirit, there is no exploitation, no hierarchy, and no biological subjugation. Every variant of humanity views every other variant with absolute equality, recognizing that all are simply different stanzas in the same grand, unfolding epic of human consciousness. The human genome becomes a living, expanding library of civilizational achievement, a canvas upon which our species writes its love letters to the universe. We are no longer the passive, fragile products of a blind, localized, evolutionary process trapped on a single, vulnerable rock. We have become the conscious, deliberate authors of our own biological destiny, turning our own code into a universal key capable of opening every doorway across the infinite expanse of the stars. We return, finally, to the quiet stillness of the present moment. We step back from the grand, sweeping vistas of the future, leaving behind both the dark, rain-slicked corporate enclaves of the genetic abyss and the radiant, sunlit starships of the open-source utopia. The visions of the centuries ahead fade away, collapsing back down through the decades, until we are standing once more within the simple, immediate reality of our own time. We find ourselves back in the year 2026. We are looking into the quiet, brightly lit hospital room in Philadelphia, where a little boy named K.J. Muldoon is playing with his toys on the floor, laughing and looking out the window at the passing sky. To the casual observer, this scene is a beautiful, deeply touching, but ultimately local story of modern medical success. A family saved from heartbreak by the brilliant intervention of dedicated doctors. But we know better. Having traced the long, historical lines of the Grand Fork that originates at this exact coordinate, we understand that we are looking at something far greater than a localized medical miracle. We are looking at the absolute point of no return for the human species. The event in Philadelphia was the crack in the dam. It was the empirical demonstration that the ancient, multi-million-year era of blind biological fatalism is officially over. The code of life has been read, it has been mapped, it has been loaded into our digital workstations, and the first lines have been rewritten. The human genome is no longer an unalterable text dictated by the random dice rolls of nature. It has become an interactive manuscript that we are actively editing. We are prone to falling into a deep, psychological trap when we contemplate the future. We often look at the terrifying scenarios of dystopia or the inspiring visions of utopia as if they are distant, predetermined stations along a track that we are passively riding toward. We read science fiction as if it is a map of a landscape we will eventually discover, completely forgetting that we are the ones pouring the concrete for the roads. The fundamental truth that we must grasp in 2026 is that the Great Fork does not lie 200 years down the timeline. It is not an issue for future generations to resolve. The Great Fork is happening right now, in the present tense, in the very choices we are making this month, this week, and this exact hour. The choice between the genetic abyss and the radiant utopia is being actively written in the legal briefs filed in patent courts today, where corporations fight to monopolize the structural secrets of life. It is being written in the funding allocations voted on by national parliaments, deciding whether genetic research will be open to the public or hidden behind proprietary walls. It is being written in the ethical debates echoing through our universities, and in the collective cultural consensus that we, as ordinary citizens, form when we talk about the value of human life and the right to health. Every time an independent researcher uploads a newly mapped protein configuration to an open-source public database, they are laying a brick on the path toward utopia. Every time a medical regulator prioritizes patient safety and democratic access over corporate profit margins, they are steering our civilization away from the abyss. Every time we assert that the biological blueprint of our species is a universal heritage that belongs to all of humanity, rather than a commodity to be bought and sold by the highest bidder, we are drawing a line in the sand against the descent into caste-based feudalism. Little KJ Muldoon, as he looks up from his toys and smiles, has no conception of the immense civilizational weight that rests upon his small shoulders. He does not know that his survival is the first trumpet blast of a new biological era. He is simply a child who was given a chance to live, to breathe the air, to grow up, and to discover the world. But we understand the scale of the moment. We know that the door to our biological destiny has been unlocked, and it can never be closed again. The tools are in our hands, the code is blinking on our screens, and the blank pages of our evolutionary future are waiting to be filled. The direction we take from this coordinate is not a matter of biological fate. It is a matter of civilizational choice. The answer is not written in our DNA. It is being written by us.